Here we are at question number 8, almost the last question in our test review for stats probability. Question number 8, a survey compared the amount of time a student studied for a test with the test score received. The graph shows the data gathered. The line of fit includes the points 167, so right about right here, and 5, 90, so it's right there. So they've already plotted the data for us, and they've already drawn the line of fit. First question is, write the equation of the line of fit in slope-intercept form. Now we've talked about this in class. We're going to have to find the slope, and we're going to have to find a known point on the graph, which we already will know once we find the slope. And we're going to start with point-slope form, and we're going to change that to slope-intercept. Now there's a little typo here. Let's go ahead and correct this. This should be y minus y1 equals slope times x minus x sub 1. All right. Not difficult to do. This is Algebra 1 skills. We're going to go to our 2 points first of all, which they've already selected for us, and we're going to label them as x sub 1, y sub 1, and x sub 2, y sub 2. And we're going to need these points to find our slope. Let's remind us, slope is rise over run, and that's going to be the change in y, or y sub 2 minus y sub 1, over x sub 2 minus x sub 1. So there's our slope. Let's go ahead and plug in the values. Y sub 2 is 90, minus y sub 1, which is 67, and that's divided by x sub 2, which is 5, minus x sub 1, which is 1. Let's go ahead and simplify that. 90 minus 67 is 23. And 5 minus 1 is 4. Let's go ahead and put that in our calculator and figure out what we get. So I've got 23 divided by 4. It's easier to work with the equation if it's in decimal form. 5.75 sounds good. The only time I might leave that in fraction form is if for some reason it just ends up being a repeating decimal. Or the best way you can do that is if you want to still use it as a decimal, just round it to 3 decimal places instead of 1. That will make your equation pretty accurate. Okay, so you've got our slope. And let's just treat this point right here, the 1, 67, as our known point, x sub 1, y sub 1. So let's take our equation and plug in what we know. We've got y, that's going to be our variable still, minus y sub 1, which is 67, is equal to slope, which is 5.75, and that's going to get multiplied by x, minus, and x sub 1 is 1. Next step, let's distribute into our binomial. So now we've got y minus 67 equals 5.75 times x, and then 5.75 times negative 1 is negative 5.75. Next step is we're going to move the 67 to the other side. Now I'm just doing this just so you see the math behind it. Let's go ahead. This is now going to be just y. Y is equal to, and we've still got 5.75x, and now we're going to have negative 5.7 plus 67. Make sure you put it in your calculator correctly. Negative 5.75 plus 67, and that's going to end up being a positive 61.25. Class, we just found our equation. This is slope-intercept form. Y equals m times x plus b. So here's our equation. Let's put it in our box. Y equals 5.75x plus 61.25. So now we know the equation of our line of fit. The next part is pretty easy. Once you know your equation, look at the question. A student studied 3.25 hours for the test. Use the equation of the line of fit to predict their test score. And we're going to predict the test score. That's the unknown. The known is hours. Let's take a look. Hours is on the x-axis. That means this is our x value. That means we're going to write our equation and substitute that for x. We've got y equals 5.75 times 3.25 hours plus 61.25. Let's go ahead and put that in our calculator and see what we get. We've got 5.75. If I can get those buttons to work. And now for some reason I'm not getting the buttons to work. There we go. Let's backspace and try again. 5.75 and then parentheses 3.25 parentheses and then we'll add 61.25 equals 79.9375, and I can round that to one decimal. That means I'll just write it as 79.9. So 79.9. I'm going to check that number in a second. Let me write 79.9. I'm going to check that because my number in my answer sheet is different than that, class. Let me just try one more time. Let's make sure we wrote all the numbers correct. 5.75 is our slope. 61.25 is our negative 575 plus 67. That looks correct. All right, let's try it one more time just to make sure. 5.75 times 3.25. This calculator is working very slow. It's making me press every key very hard. 3.25 plus 61. I should have checked my display before I pressed the equal sign. And now let's press equal. Yeah, 79.9. All right, so our predicted score is 79.9%. All right, and we can predict any score based on the number of hours. Remember we learned in one of our graphs, though, for scatter plots, as you start picking hours outside of this graph, and you might end up with pretty accurate answers. Inside this graph, probably a pretty good predictor. All right, so there's number 8. Let's take a look at number 9. You and your friend enter a raffle. You buy 1 ticket, your friend buys 2, and there are 9 other tickets purchased. There will be 2 tickets selected, class. That means you've got 2 trials. And when a ticket is drawn, it is not put back. That means we have dependent probability. Once you pick 1 ticket and you don't put it back in, the next probability is going to depend on the fact that you've already done something. So these are dependent events. And I'm going to write a little chart right here. This helps me out sometimes. I'm going to say that I'm going to put for me, I'm going to put for, or let's say you have 1 ticket. Your friend has 2 tickets. Other people have 9 tickets. And that means my total tickets are adding these together. 9, 10, 11, 12. We got a total of 12. That will help me with my probabilities. Okay, what is the probability that your friend is selected first and then you are selected second? So your friend first and then you second. Now remember, these are 2 trials, so 2 trials, and that means we are going to multiply probabilities. What's the probability your friend is selected first? Well, your friend has 2 tickets out of a total of 12, so my friend is going to be 2 out of 12. Okay? Now, what's the probability that I'm selected or you're selected second? Well, there's still 1 of my tickets in the barrel, or in the raffle barrel. But now there's no longer 12 tickets. There's only 11. So we've got a 1 ticket is mine out of 11 total. And let's just kind of label these so you see. Here's trial number 1. Here is trial number 2. And we're going to have to multiply these together to find the probability that they both happen in a row. 2 times 1 is 2. 12 times 11, you multiply that out, that will be 132. So our fraction is we've got 2 out of 132. Notice, we are multiplying. Don't add. It's easy for students to go, oh, 2 plus 1 is 3. 12 plus 11 is 23. No, we multiply. That's why I wrote down. 2 trials means we are multiplying. 2 divided by 132. I'm going to put that in my calculator, and then I'm going to multiply it by 100, and that's going to give me my decimal answer, 1.5%. All right, next one. What is the probability that neither you or your friend is selected in either trial? So neither of us are selected in either trial. Well, that means for trial number 1, it's going to be somebody else besides us. That's 9 possibilities out of 12. So 9 of the tickets are not us out of 12 total. Now think about this, class. In the second trial, one of the other tickets was already picked. That means in the second trial, there's no longer 9 other tickets. Now there's only 8. So now there's only 8 left in trial number 2. Now how many tickets are left in the barrel? Well, we already picked one and we're not returning it. Remember, the whole story tells us you don't put it back. So we know that in our second trial, it's dependent on the first one. We're only going to have 11 tickets left. So the first pick, we have 1 other ticket. There's 9 tickets out of 12. In the second trial, there's only 8 other tickets left. And there's only a total of 11 tickets left in the raffle barrel. So that means our fraction is now changed to 8 over 11. Multiply 9 times 8, and that's 72. Multiply 12 times 11, that's again 132. So our fraction is 72 out of 132. Divide that out and multiply by 100, and you got 54.5%. Last one. What is the probability that your friend wins in both trials? That means your friend gets picked the first time and your friend gets picked the second time. All right, so again, we are doing 2 trials, so we are multiplying the events together. Let's take a look at trial 1. So trial number 1, your friend has 2 tickets out of a total of 12. So they've got 2 out of 12 chance of winning. 2 out of 12. And now in trial number 2, we're going to assume if your friend wins both times, they don't have 2 tickets left in the barrel on the second trial. They only have 1 because the first one they got picked. And there's not 12 tickets left in the barrel. There's only 11. So in this case, if you want to find the probability that your friend wins both times, you're going to have to multiply these 2 probabilities together. 2 times 1 is 2. 12 times 11 is 132. Notice it's the same probability in the denominator every time, because if we take 1 ticket out, we're always going to go from 12 to 11. So that's 2 out of 132, which is actually the same thing we figured out in the first question. 2 divided by 132 times 100 is 1.5%. So hopefully that explanation will help you to figure out how to deal with this raffle problem. And that's it for a test review.